Okay, so this is SEC 2018 Cert Higher Level Maths, Paper 1, Question 9. It's a sequences and series question. The diagram below shows the first 4 steps in an infinite pattern which creates a, I'm not going to attempt to pronounce that, triangle. The sequence begins with a black equilateral triangle. Each step is formed by removing an equilateral triangle from the center of each black triangle in the previous step, as shown. Each equilateral triangle that is removed is formed by joining the midpoints of the sides of a black triangle from the previous step. The table below shows the number of black triangles at each of the first 4 steps and the fraction of the original triangle remaining at each step. Complete the table. I want to point out that this is really important. This is not T1. This column here is always going to be T1 because it's the first step. This is sort of T0. This is T1. This is the important first term. That's possibly the most important part of the question that people make mistakes on. So the number of triangles, we start off, we can count these fairly easily. 1, 2, 3, 3. 1, 2, 3, 4, 5, 6, 7, 8, 9, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 27. So that one's easy enough to do. The number of black triangles. The next part, the fraction of the original triangle remaining. So they're giving us the 9/16 here. We can see that this is split up actually into 4 triangles, where how many of them are black? 3. So 3 out of the 4 are black, or 3/4 of the original is remaining. Then consider this then. This is split up into 1 triangle, 2 triangles, 3 triangles, 4 triangles. Each one is split up into 4 triangles. So there'd be another 4 here. There'd be another 4 here. And imagine the one in the middle. I just would have to rotate this. So there's 4, 8, 12, 16. Now, how many of them are black? 9 out of 16. And then similarly, again, just on a smaller scale, 1, 2, 3, 4. 4, 8, 12. The one in the middle would be 16. So for each sort of big triangle here, there's 16, and there's 4 of these triangles. So 4 times 16 is 64. How many of them are black is 27. And that's the question done. So a nice easy one to ease us into it, I suppose. Write an expression in terms of n for the number of black triangles in step n. So as I pointed out, T1 is going to be from there and moving onwards then. So we know it's a geometric series where the first term is not 1, the first term is 3. We know the common ratio, what we're multiplying by. So what do I have to multiply this by to get to this? Would be 3, and check, does it carry across? Yes, it does. So or is 3. From our log tables, Tn for a geometric series, fill in everything that we know. Now, interesting, because they're the same base, 3, this is 3 to the power of 1, so it's the same base. What do we do to the powers? When we're multiplying and it's the same base, what do we do to the powers? You add them. You know that. So then this would be n minus 1 plus 1, which would just give you 3 to the power of n. Step K is the first step in the pattern in which the number of black triangles exceeds 1,000 million for the first time. Find the value of K. So Tn we know is 3 to the power of n. When is Tn greater than 1,000 million? And that's actually a billion. I don't know why they don't call it a billion. When is Tn equals to 1 by 10 to the power 9? Then K will be the next whole number. So if I find when it's equal to it, I will then round up to the next term number, which would be the one when it exceeds, is the key word, okay? So I'm setting 3 to the n is equal to 1 by 10 to the power of 9. Remember, that's a whole number itself. The unknown is the power. because the unknown is the power, I will be using logs. So from page 21 of your log tables here, this is straight from page 21 of your log tables, we can spot that, or we'll just match things up. A is going to be 3, n is going to be x, I wanted a different colour, 1 by 10 to the power 9 is going to be y, and match those up, a and x on its own, which leads us over to here. We can type this into our calculator, get n, so this is when it would be equal to it. So when will it exceed it would be number 19. So this is a very similar question. Step H is the first term in the pattern in which the fraction of the original remaining is less than 1/100th of the original triangle. So the pattern is 3/4, 9/16, 27, 64ths, as we have here, 3/4, 9/16, 27, 64ths. And remember, T1 comes from this column here because it's step 1, as it clearly says there. So, oops, skip the question. We want to find Tn, the general term for this pattern. So we're finding that again straight from the log tables, our formula. We know A is going to be the first term, and we know the common ratio is going to be what am I multiplying by T1 by to get the T2, or is equal to T2 over T1, which is 9/16 all over 3/4, which I find to be 3/4. So, or the common ratio. And we're in a very similar situation. We're multiplying with the same bases. Remember, it's like x to the power of 1 by x to the power of n minus 1. That's all just going to work out to be x to the power of 1 plus n minus 1, which would just be x to the power of n. So this is rough work here. So that's why we get down to this point right here. So that's a general term for the fraction of the original triangle left. So when will Tn be equal to 1/100? And then the next term will be the term where it's less than it. 1/100 here. So this is Tn is equal to 1/100. We're doing our matchy thing again. Our A, N, and Y, which leads us down to here. And you can type this into your calculator. So the next term would be, H would be the 17th term. What fraction of the original triangle will remain after infinite number of steps? So we're still dealing with the fraction that is left. So this is the series that we're dealing with. It's a geometric series where or is less than 1. As n tends to infinity, then Tn is going to tend to 0. Or you could think of the limit. If you kept repeating the pattern, it's very easy to logic this out in your head. Multiply by 3/4, multiply by 3/4, multiply by 3/4, and you keep multiplying by 3/4. Type 27/64 into your calculator, and then multiply it by 3/4, and then multiply that by 3/4, then multiply that by 3/4, then multiply that by 3/4. Your answer is getting smaller and smaller and smaller and smaller and smaller and smaller and smaller. So 3/4 to the power of infinity is going to go to 0. So it tends to 0 is our answer. And think of that, any fraction that is smaller than 1. Think of any fraction in your head. Think of any fraction in your head that is smaller than 1. I'm going to go with 3 divided by 100. 3 divided by 100, 3/100ths. And I'm going to square it. I'm going to multiply it by itself. And then I'm going to keep multiplying by 3/100 on my calculator, and I keep hitting the equal sign, and you'll notice it gets very quickly to scientific notation. I'm already on 1.43 by 10 to the minus 23, so you're looking at 22 zeros after the decimal point before you get to the digit 1, and you keep hitting equals, and your calculator will even eventually tend it to 0 or let it go to 0 if you keep hitting your equals on your calculator. I'm at by 10 to the minus 80 now. I don't know how far this goes. By 10 to the minus 100. Yeah, when you get to 10 to the minus 100, your Casio anyways will say it's 0 because it's basically 0. The side length of the triangle in step 0 is 1 unit. The table below shows the total perimeter of all the black triangles in each of the first 5 steps. Complete the table below. So the perimeter. So you know the perimeter is the outside bit. Well, if that's 1, this is a half, 2 halves, 3 halves, 4 halves, 5 halves, 6 halves, 7 halves, 8 halves, 9 halves. So it's 9 over 2. If this was a half, this is going to be half of a half, which is a quarter. 1 quarter, 2 quarter, 3 quarters. And how many black squares are there? 1, 2, 3, 4, 5, 6, 7, 8, 9. So it's 9 times 3 quarters. So it's 27 over 4 is going to be the perimeter of that. What about this? If this whole unit is 1, and this is half, and this is a quarter, and this is 8, well, this is going to be 1/8 plus 2/8 plus 3/8. 3/8, that's the area. 3/8 is the perimeter. 3/8 is the perimeter of one little small one. So 1, 2, 3, 4. Oh, well, I've already counted it. 3/8 times 27. So 3 divided by 8 times 27. The perimeter is 81 over 80. Perimeter is 81 over 80. And then you can spot that this is a geometric series. Multiply by 3 over 2, I think it is. Yeah, geometric series. Find the total perimeter of the black triangles in step 35. Now this is weird. Watch the perimeters. What's happening to the perimeter? 3 goes to 9 over 2. 9 divided by 2 is 4.5. 4.5. The perimeter has gotten bigger. 27 divided by 4. That's 6.75. The perimeter is getting bigger. So the more black triangles are, the bigger the perimeter has gotten. So we have our geometric series. Again, T1 is coming from the 9 over 12, not the T0. We know it's a geometric series. We know the first term is 9 over 2. We know the common ratio, what we're multiplying by. I already just highlighted that. And we've gotten our formula for the general term of a geometric series, given the perimeter. Yeah, want to find it in the 35th. So we're saying 35 for n. Multiply it out. And the perimeter is huge. The perimeter is massive, which is possibly a little disconcerting. But it's actually true. And use your answer from part C, part 1 to comment on the area. Well, the area is going to tend to 0, we just said, and the perimeter, where the perimeter tends to infinity. So the more black triangles there are, the bigger the area gets. And if the number of black triangles tends to infinity, well, so too does the perimeter tend to infinity. Just have time quickly to look at the marking scheme for the question. So you're looking at 55 mark question. Pretty long question, I think, for a 55 mark question. Not the nicest. Look, it was actually pretty easy, but I imagine it caught people out. It's just the wording of these sequences and series questions a little strange. So A is 10 marks. B part 1 is 5 marks. You can pause the video at any time, obviously. B part 2, 5 marks. C1, 10 marks. C2, 5 marks. D1 is 10 marks. 10 marks for finding the perimeter. There's a fine point. Like, that's crazy. D2, 5 marks. D3, 5 marks. I think in general, actually is a nice question, but I suppose some of them are asked a little funkily. Hopefully you found the video useful. Anyways,